10 coulomb is accelerated in a vacuum from rest at 0 volts towards a plate at 40 kilovolts. Calculate the kinetic energy of the electron. Solution. The kinetic energy Ke of the electron is equals to 1 over 2 mv squared, which is equals to charge times potential difference, which is equals to EV. Ke is equals to 1.6 times 10 raised to the power 19 times 40,000, which will give us 6.4 times 10 raised to the power minus 15 joules. Example 3. An electron jumps from an energy level to another in an atom radiating 4.5 times 10 raised to the power minus 19 joules. If the Planck's constant is 6.6 times 10 raised to the power minus 34 joules seconds, what is the wavelength of radiation? The equivalent velocity of light equals to 3.8 times 10 raised to the power 8 meters per second. Solution. The energy of the photon, capital A, is equal to hv, but V is equal to C over lambda, where V is equal to frequency of radiation, C is equal to velocity of light, lambda is equal to wavelength of radiation. E1 minus E2 is equal to hc over lambda. We now substitute the value to get 4.5 times 10 raised to the power 19 minus 19 is equal to 6.6 times 10 raised to the power minus 34 times 3 times 10 raised to the power 8 all over lambda. Lambda is now equal to 6.6 times 10 raised to the power minus 34 times 3 times 10 raised to the power 8 all over 4.5 times 10 raised to the power minus 19, which will give us 4.4 times 10 raised to the power minus 7 meters. Example 4. The ground state of hydrogen is minus 13.6 eV and the first excited state is minus 3.4 eV. Calculate the wavelength of the radiation emitted if the electron returns from the excited state to ground state. Solution. Energy loss of atom is equal to, in bracket, minus 3.4 minus 13.6, which is equal to 10.2 eV. Quantum energy of radiation emitted, hv, is equal to 10.2 eV, which is equal to 10.2 times 1.6 times 10 raised to the power minus 19, which is equal to hc over lambda. Lambda is equal to wavelength. Lambda is equal to hc over 10.2 times 1.6 times 10 raised to the power minus 19, which is equal to 6.6 times 10 raised to the power minus 34 times 3 times 10 raised to the power 8 all over 10.2 times 1.6 times 10 raised to the power minus 19. Lambda is now equal to 1.2 times 10 raised to the power minus 17 meters. Photoelectric effect. Einstein's photoelectric equation. From Einstein's equation, photoelectric law, E is equal to half HF minus HFO. If WO is written as HFO, then we have that E is equal to EV, which is equal to HF minus WO, which is equal to H in bracket F minus FO, where E is equal to maximum kinetic energy that can be imparted to the photoelectrons. H is Planck's constant. F is equal to frequency of incident light. FO is equal to the threshold frequency, which must be exceeded for electrons emission occur. WO is equal to HFO, is equal to the work function energy, which is the least or minimum energy required to extract an electron from a metal surface. EV is equal to kinetic energy of electron. HF is equal to quantum of energy in incident light. Hf minus Wo is equal to maximum energy of liberated photoelectrons. Example 1. Calculate the frequency of photons whose energy is required to eject a surface electron with a kinetic energy of 1.97 times 10 raised to the power minus 16 eV if the work function of the metal is 1.33 times 10 raised to the power minus 16 eV. Taking 1 eV equals to 1.6 times 10 raised to the power minus 19. H equal to 6.60 times 10 raised to the power minus 34 joules seconds. Solution. Capital E is equal to HF minus HFO. HF is equal to E plus HFO. F is equal to capital E plus HFO all over H. F, substituting the values, we now have F is equals to, in bracket, 1.97 times 10 raised to the power minus 16 plus 1.33 times 10 raised to the power minus 16 times 1.6 times 10 raised to the power minus 19 all over 6.60 times 10 raised to the power minus 34, which we now have 3.3 times 10 raised to the power 16 times 1.6 times 10 raised to the power minus 19 all over 6.60 times 10 raised to the power minus 34. F is equal to 3.30 times 1.6 times 10 raised to the power minus 34 all over 6.60 times 10 raised to the power minus 34, which gives us 0.08 hours. Example 4. The work function of lithium is 2.3 eV. Calculate the maximum energy in joule of photoelectrons liberated by light of wavelength 3.3 times 10 raised to the power minus 7 meters. The threshold wavelength of the metal. Solution. From instant photon law, Hv minus Wo is equal to maximum energy of liberated photoelectrons. Now, Hv is equal to quantum of energy in incident light, which is equal to Hc over lambda. Hv is equal to, substituting the values, we now have 6.60 times 10 raised to the power minus 34 times 3 times 10 raised to the power 8 all over 3.3 times 10 raised to the power minus 7 is equal to 6.0 times 10 raised to the power minus 19 joules. Maximum energy of liberated photoelectrons is equal to 6.0 times 10 raised to the power minus 19 minus 2.3 times 1.6 times 10 raised to the power minus 19 joules, which is equal to 2.3 times 10 raised to the power minus 19 joules. The threshold wavelength is the longest wavelength that will just produce photoelectrons. When the surface is illuminated, the incident frequency is VO. Then Hv is equal to Wo, which is equal to Hc over lambda. Lambda is equal to Hc over Wo, which is equal to 6.6 times 10 raised to the power minus 34 times 3 times 10 raised to the power 8 all over 2.6 times 1.6 times 10 raised to the power minus 19, which will now give us 5.4 times 10 raised to the power minus 7 meters.